encounter different bodies of knowledge, and one of which is what? It's mathematics, of course. In a world full of the unthinkable, intellects have paved the way for us to understand incredible systematic way of calculating things, such as the calculation of profits and loss with the use of graphs, and calculation the rates of change of temperature, and so much more. Now, that is where our agenda goes into. You know why? Because in mathematics, differential calculus is a subfield of calculus that studies the rates at which quantities change. It is one of the two traditional divisions of calculus, the other being integral calculus, which is the study of the area beneath a curve.
In mathematics, we have something called differential calculus. What is it? It is a subfield of a calculus that studies the rates at which quantities change. Its primary objects of the study are the derivative of a function, which is the instantaneous rate of change of a function with respect to one of its variables. Differentiation is the process of finding the derivative of a function. It is also used to determine the slope of a nonlinear function like a curve.
With that said, let's try to solve the differentiation problem of dy over dx if y is equals to square root 3x to the power of 3 plus 4x plus 1. Here, dy over dx is a notation we use to indicate the differentiation with y with respect to x. To begin solving, we write dy over dx, which means we are now starting to differentiate the expression.
Note that this expression can be written as a quantity of 3x cubed plus 4x plus 1 raised to the power of 1/2. As a reminder, one can convert radical expression into fractional exponent by taking the radicand as the base and raising it to the exponent with the power of the radicand as the numerator and the index as the denominator. In this case, the radicand is 3x cubed plus 4x plus 1, which is the base. The power of the radicand is 1, meaning that the numerator is 1, and 2 is the index, meaning the denominator is 2.
The next step is applying the chain rule of differentiation. The chain rule is a process in determining the derivative of a composite function. Here, it states that we must take the derivative of the outside function, leaving the inside alone, and multiplying it to the derivative of the inside function. An example, to find the derivative of the outside function, we use the power rule, which states that if k is a real number, then the derivative of the function f of x equals to x raised to the power of k is the derivative of x raised to the power of k is equals to k times x raised to the power of k minus 1, where k is the real number. So, we have 1/2 times the quantity of 3x cubed plus 4x plus 1 raised to the power of 1/2 minus 2 over 2, because 2 over 2 is equals to 1.
Now, we multiply what we have with the derivative of the inside function, which we still get using the power rule. So, we start with the derivative of 3x to the power of 3, which is 3 times 3 equals 9. Copy the variable x and raise it to the power of 3 minus 1, plus the derivative of 4 times, which is 1 times 4 equals 4. Copy the variable x, raise it to the power of 1 minus 1, and the derivative of 1 will be 0. Because the constant rule states that the derivative of a function is 0, but it is not necessary to write it down. Now,
before proceeding to the next step, we must apply simple subtraction. Here we have 1/2 minus 2 over 2 is equal to negative 1/2. For the derivatives of the inside function, 3 minus 1 is equal to 2, and 1 minus 1 is equal to 0. And when something is raised to the power of 0, it will be equal to 1. Therefore, 1 times 4 is 4. In the next step, we must multiply 1/2 and 9x squared plus 4, which will give us 9x squared plus 4 over 2. We then multiply this to the inside function we left alone a while ago, which is the quantity of 3x cubed plus 4x plus 1 raised to the power of 1/2.
Since we can't have a negative exponent, we'll express this with a positive exponent, using a raised to the power of negative n equals 1 over a raised to the power of n. So first, copy 9x squared plus 4 over 2 and multiply it with a newly transformed expression, which is 1 over the quantity of 3x cubed plus 4x plus 1 raised to the power of 1/2. Now, we multiply both expressions, which gives us 9x squared plus 4 over 2 times the quantity of 3x cubed plus 4x plus 1 raised to the power of 1/2. The final step to do is to transform the fractional exponent back to radical form. This gives us 9x squared plus 4 over 2 square root of 3x cubed plus 4x plus 1, which gives us our final answer.
And that's it for this video. Thank you guys for your time and effort in watching this video. We do hope that you have understood well how we solve the problem associated to the differential calculus. And always remember and bear in mind that as the world changes, we must adapt to it, observe it, and calculate it. Thank you.